Bismillahirrahmanirrahim. In this lecture, we are solving problem 4 from HVAC, heating, ventilation and air conditioning. So the statement of the problem is a mixture of dry air and water vapor is at a temperature of 21 degrees centigrade under a total pressure of 736 millimeter of Hg. The dew point temperature is 15 degrees centigrade. Find number 1 the partial pressure of water vapor, relative humidity, specific enthalpy of water, enthalpy of air per kilogram of dry air, and specific volume of air per kilogram of dry air. So given data is a mixture of dry air and water vapor is at a temperature of 21 degrees centigrade. So here T1 is a mixture of air and water is 21 degrees centigrade under a total pressure P1 is equal to 736 millimeter of Hg. Convert this pressure into Newton per square meter. So P1 is equal to 736 multiplied by 133.5 Pascal or Newton per square meter. So P1 is equal to 1 millimeter of Hg is equal to 133.5 Newton per square millimeter. So the final answer is 98256 Newton per square meter. The dew point temperature is 15 degrees centigrade. T2 is equal to 15 degrees centigrade. Required number 1. The partial pressure of water vapor is represented by PV. Number 2. Relative humidity. Relative humidity is represented by phi. Number 3. Specific humidity. Number 4. Specific enthalpy of water vapor. Specific enthalpy of water vapor. Number 5. Enthalpy of air per kilogram of dry air. Enthalpy of air per kilogram of dry air. Number 6. Find specific volume of air per kilogram of dry air. So we start solution. In solution, first we have to find partial pressure of water vapor. So the temperature of dew point or water vapor is 15 degrees centigrade. So we will find partial pressure of dew of water vapor at 15 degrees centigrade because the temperature at dew point is given to us as 15 degrees centigrade. So from saturated steam table, the partial pressure of water vapor at 15 degrees centigrade is 15 degrees centigrade is dew point temperature. So 15 degrees centigrade is not available in saturated steam table, so we do interpolation for this. So temperature in degree centigrade, and pressure in Newton per square millimeter. So in steam table 14 degree centigrade is available and 15.9 degree centigrade. At 15 degree centigrade the pressure is given as 1600 Newton per square meter or 1600 Pascal. 15.9 the pressure is 1800 Newton per square meter. No need of this because this is P is Newton per square meter. And at 15 degree centigrade we have to find partial pressure of vapor from interpolation. So by interpolation, third minus first divided by third minus second. 15.9 minus 14 divided by third minus second. 15 minus 15.9 minus 15 is equal to 1800 minus 1600 divided by 1800 minus PV. So this is simple calculation. Calculate this and find the first value, which is 1705.3 1705.3 Newton per square meter. Divide this value by 1000, so the final answer will be in kilopascal, which is equal to 1.7053 kilopascal. Now in part 2, relative humidity is required. Relative humidity is denoted by phi, and relative humidity is equal to partial pressure of water vapor divided by saturation pressure multiplied by 100. So PV is already found by us, which is equal to 1705.3, and we find PS saturation temperature at temperature of 21 degree centigrade. So from saturated steam table, from saturated steam table at temperature is equal to 21 degree centigrade, we have to find saturation pressure PS, but 21 is not given in table, so we will do interpolation. Temperature in degree centigrade, saturation pressure in Newton per square meter. In table 20.4 degree centigrade and 21.7 degree centigrade is available. At 20.4 degree centigrade, saturation pressure is 2400 Pascal, and 21.7 the saturation pressure is 2600, and at 21 PS is required. So by interpolation, third minus first, 21.7 minus 20.4 divided by 21.7 minus 21 is equal to 2600 minus 2400 divided by 2600 minus PS. Now this is simple calculation. Calculate this and find PS. So PS is equal to 2494.3 Newton per square meter or Pascal, and kilopascal divided by 1000. So this will be equal to 2.94.3 kilopascal. Now we can easily find relative humidity, which is equal to PV divided by PS multiplied by 100 and in percent, which is equal to PV is 1705.3 Pascal or Newton per square meter, and PS is 2494.3 Pascal multiplied by 100%. So relative humidity will be equal to 68.36%. 68.36%. Now we are solving part number 3, which is specific humidity. So the formula for specific humidity from CP Aurora book is 0.622 into PV divided by P total minus PV, and the proof of this formula is available in the CP Aurora book. So specific humidity is equal to 0.622 into pressure of water vapor is 1705.3. PV is given to all defined by us 1705.3 divided by PT minus PV. So as we know that PT is equal to pressure of air plus pressure of water. Total pressure is equal to pressure of air plus pressure of water vapor, and pressure of air is equal to total pressure minus pressure of water vapor. So this is equal to this is given to us pressure, total pressure P1 is given to us is 9825.6. 9825. Total pressure is given to us in given data, which is equal to 9825.6. 9825.6 Pascal or Newton per square meter. So pressure of air will be equal to P total. So P total is 9825.6 minus pressure of vapor is 1705.3. 1705.3. So this actually this is PT minus PV. Actually this formula is 0.622 into PV divided by PA, and which is further equal to 0.622 pressure of water vapor divided by PA is equal to PT minus PV. From this equation this is equal to PT minus, so put here 9825.6 minus 1705.3. Here unit is Pascal and here unit is Pascal, so Pascal will be cancelled with Pascal, and specific humidity will be equal to 0.011 kilogram of water vapor per kilogram of dry air. So part 3 is solved. Now we are solving part number 4, specific enthalpy of water vapor. So part number 4, specific enthalpy of water vapor. So per specific enthalpy of water vapor. So formula for specific enthalpy of water vapor from CP Aurora book is CPW, specific heat capacity at constant pressure of water vapor into temperature of W, plus HFG, and temperature here is 21 degrees centigrade. So CPW is constant value, which is equal to 4.1868. Temperature of water is given to us 21 degrees centigrade, and HFG we can find this value from table. So from saturated steam table at temperature is equal to 21 degrees centigrade. HFG is 24.5 to 2452 kilojoule per kilogram. So enthalpy of water vapor is equal to specific heat capacity at constant pressure of water vapor is equal to 4.1868 kilojoule per kilogram per Kelvin. Temperature is 21. We can write this in Kelvin because this difference is constant. So and HFG value is 2452 kilojoule per kilogram. This Kelvin will be cancelled with Kelvin. So specific enthalpy of water vapor will be equal to 2539.9 kilojoule per kg of water vapor. Now part number 5 is specific enthalpy of water vapor per kilogram, specific enthalpy of air per kilogram of air. So specific enthalpy is equal to specific enthalpy of air plus specific humidity and specific enthalpy of vapor. So Cp of air is equal to 1 for H is equal to Cpt. So I can write this formula as Cp of air into temperature plus specific humidity into specific enthalpy of water vapor. All values are known. Specific enthalpy of air is 1.005 kilojoule per kilogram per Kelvin. Temperature is 21 Kelvin. We can write degree centigrade and Kelvin because difference is same. And specific humidity is 0.011 multiplied by specific enthalpy is 2539.9 kilojoule of water vapor is kilojoule per kilogram. This video. So enthalpy of dry air per enthalpy of air per kilogram of dry air is, simplify this, Kelvin will be cancelled with Kelvin. This will be kilojoule per kg and this will always be in kilojoule per kg. So final answer will be 49.04 kilojoule per kilogram of air per dry air. Now finally we are finding specific volume of dry air per kilogram of air. So specific volume of dry air is equal to RT divided by P. PV is equal to RT. So V is equal to RT divided by P. R of air and pressure of air. So RA per air is equal to 287.7 Newton meter per kilogram per Kelvin multiplied by temperature is 21 Kelvin divided by pressure of air known to us 96550.7 96550.7. Exactly, this is pressure of air. Total pressure minus pressure of water vapor. Newton per square meter. So this Kelvin will be cancelled with this Kelvin. This Newton will be cancelled with this Newton. Meter square in double division this will be meter cube per kg. So specific volume of air per kilogram per dry air is 0.875 meter cube per kg of air per dry air. So this is the final answer. And for more videos please like and subscribe my YouTube channel. Thank you.